So in this video, we are going to do a few examples related to bonds. Let's begin with the first example. A 10-year 1,000 par value bond bearing 10% coupon rate payable semi-annual and redeemable at 105 is bought to yield 8% convertible semi-annual. Find the price, verify that all formulas produce the same answer. So in this example, I'm going to use one formula, and then you can try to use the other formulas. Remember, we learn 4 different formulas. So let's write down what we see here. It's a 10-year 1,000 par value bond. So the face value, the value which is used to calculate coupon is $100. 10% coupon rate payable semi-annual. So so the coupon amount is FR time 10%. I mean the F time R. But it is nominal rate, so you have divided by 2 since it's semi-annual. So you would get $5. Then it is reviewed at 105, so the C is 105. Okay, the face value is the value you use to calculate the coupon amount. Okay? And both to yield 8% convertible semi-annual. So basically this is nominal rate. So the per coupon period of 6 months is only 4%. So what's given is actually J2, which is 8%. And from here, you can take the J, which is effective rate per coupon period, which is going to be 4%. Okay? Because this is nominal rate. Find the price. So let me draw the timeline just to understand what how this bond looks like. It's 10 year. So you have 0, 0.5. In 6 months, you get $5. 1 year, $5. 1.55. So this continue. And the end of the 10th year, you get $5 and 105. Okay, so that's how it's looking. Now, when you get this kind of problems, actually, let me first write the basic price formula. So basic price formula says price equal what? Price equal present value of coupon amount plus present value of redemption amount. No? So this is basically in mathematical notation, this is FRAN under rate J plus CVN. Okay. In here, V is 101 plus J. J is 4%. Okay, the one we just get. AN in here, N is how many number of payments, which is going to be 20 because every year you get 2 coupons. So 10 times 2 because every 6 months you get a coupon. So N is 20. Okay. And FR is going to be 5 because we just calculate the coupon amount is $5. And the C is 105. Now, yes, this is the formula, but the way you calculate the price, basically you use your calculator. So what you do, you enter these things into calculator. So you would enter N to be 20, payment to be $5, future value to be 105. Okay, now you can see both are positive because you are getting that. Payment you receive, redemption amount you receive. So both are positive. Then the rate, you can say IOY, either you can use 4% or you can use 8%. So if you use 8%, let's say you use 8%, then you have to set compounding per year to be 2, payment per year to be 2. Okay. Or you can set IOY to be 4%, but in that scenario, you have to say compounding per year 1, payment per year 1. Okay. Because it's not, this one is nominal. Okay. This one is effective per coupon period. Okay. So you have to understand that difference. Okay. Okay. So I'm going to use this approach. Okay. You can check the other one, it will give you the same answer. So let's use our calculator and see what do we get. So let me reset this one. Yes. Okay. So let's enter this into calculator. So we have 20 as N, 8 as IOY, then second IO payment per year is 2, and company per year 2. So let's split from there. Then payment amount 5, future value 105, and we are calculating for percent value. So complete percent value, and I get 115.87. So the percent value is 115.87. So that's basically the price. Okay, so the price for the price of the fund. So that's how you do that problem. You can try the other other three formulas. So we use the basic price formula. You can try the other formulas and you should get the same answer. Okay, so the second question is from exam FM. So this one show you like what kind of question you are going to see in the exam FM. So Susan can buy a zero coupon bond. Now remember, zero coupon means you don't get any coupon, so no coupon. Okay, only redemption amount. That means you have to wait until bond mature to get anything out of your investment. Okay, a zero coupon bond that will pay 1,000 at the end of 12 years, and is currently selling for 624.60. So let's draw the timeline and see how it's look like. Here 0. This is price. And then this is 12 years, and at the end of 12 years, you get 1,000 if you buy this bond. Okay. Instead, she purchased a 6% bond with coupon payable semi-annual that will pay 1,000 at the end of 10 years. Okay, so instead of buying that, so she bought 10-year bond, which pay 1,000 at the end of 10 years. Coupons are semi-annual. Now we don't know. So it's not mentioned like what you should use as the face value. If it is not there, you always use the redemption amount to calculate the coupon amount. So this one is 6% coupon payable semi-annual. So the coupon amount FR is going to be 1,000 times 6% is twice per year. So it's you divide by 2. So that would give you 30. Okay, so coupon amount is 30. This is 0.5, 1, 9, 9.5, so it's 30, 30, and then the last year also 30. These are coupon amounts. Okay, so these are coupon amounts. Okay, so if she pays X, she will earn the same annual effective interest rate as the zero coupon bond. Calculate X. Okay, so here is the price. Price is X. Okay, this is the price. So the question is asking us to calculate X, but we need to know the rate we should use to discount this. Okay, you have to discount it back to the time 0. When you're discounting, you have use rate J. Now that rate J is same for the zero coupon bond. So you have to use the same discount rate. So from the first one, let's calculate the rate J. So you can see 624.60 equal what? Now we have to be careful. Okay, so what is this rate? Is it annual or is it 6 months? If it is 6 months, then you have actually 24. Okay, then this should be 24 because then it's going to be there are 24 6 months. Okay, so if it is annual effective rate, then it's 12. So I'm going to define J as effective rate for 6 months. Why is that? Because in the second one, we need effective rate for 6 months. Okay, that's why I'm using 6 months. So effective rate for 6 months, then this would be V24. Okay, because for 1 year, then this one would be J 0.5, then 1, this one would be J. Okay, so for the 12 years, it would be actually 24 6 months. So 624.60 is going to be what? V24 times 1000. From here, we can calculate this one. So that's going to be, I mean, you can divide this one by 1000, which is going to be 0.62460. From here, you can get V. V is what? So let's calculate this. 62460 to the power 1/24, which is going to be 0.980580869. And we know that V is what? V is 101 plus J. That's what 0.980580869. So 1 plus J is basically inverse of this. So if you take 1 over this, then you get 1 plus J. So I can take the inverse function in the calculator, and I will get 1.019803702, and you subtract 1 both sides and you get J. So J is going to be 0.019803702. Now don't forget that this is 6 months. Okay, 6 month effective rate, not 1 year. Okay, so then I come back to here. So for this one, I had to calculate price. So what I do, I enter the values. So there are payment price is 30, future value is 1000, and N is 20. There are 20 payments, and the rate we just found is, so if I multiply this one by percentage, it's going to be it's going to be 1.98. So IOI is 1.98. I leave like that, 1.98. Then compounding per year is, if I use 6 months, then compounding per year should be 1. Okay, and the payment per year is 1. Okay. If you know the nominal rate for 1 year, then you can change it to compounding per year 2 and payment per year 2. But since this is 6 months, I had to leave it as 1. So now let's bring calculator and calculate the find the answer. Okay, so let me reset this one. So payment is 30. Future value is 1000. Um, 24N 1.984 IOY. Then this one should be 1 and 1. And then I'll compute the percent value. So it's 1167 and 1. So that's the price of the bond. If you need the same same rate. Okay, so let's go next one. Again, this is exam FM problem, and you can see what kind of problems you are going to see. You are going to get in during the exam. An investor borrow an amount at an annual effective interest rate of 5% and will repay all interest and principal in lump sum at the end of 10 years. She used the amount borrowed to purchase a 1,000 par value 10-year bond with 8% semi-annual coupon, bought to yield 6% convertible semi-annual. All coupon payments are reinvested in at nominal rate of 4% convertible semi-annually. Calculate the net gain to the investor at the end of 10 years after the loan is repaid. So let me erase this side and then we do this problem. So here you can see that the problem is actually two parts. First, you borrow money. So you need to know how much you really borrowed. And then the person reinvesting the coupon amount. So then that we need to calculate what would be the aggregate sum of those deposits, the future value of those deposits into the separate account. So let's start. So this one says investor borrows amount at annual effective rate, so 5%, and will repay all interest and principal in a lump sum at the end of 10 years. Okay, so borrowed what? We don't know the amount X for 10 years at rate of 5%. Okay, so that's. She used the amount borrowed to purchase 1,000 par value 10-year bond with 8% semi-annual coupon bought to yield 6% convert semi-annual. So let's draw that. The timeline. This is 10-year bond. Coupon every 6 months. Semi-annual coupon. So the coupon amount, you can see the face value is 1,000. And the rate we should use is 8% divided by 2 because it's a nominal rate. So you can see that's going to be 40. Okay, so and the redemption amount is going to be 1,000. Okay, so there's no specific mention about different redemption amount. So now the rate we should use to discount is what? 6%. Again, this one is nominal. Okay, so J2 is 6%. So that means per 6 months, it's going to be 6% divided by 2, which is 3%. Okay. So now we can discount all of this. So the price would be what? Price would be FR AN J plus CVN, and V is basically 101 plus J, and J is actually 3%. Okay, so this is J. And what's the N? N is going to be, there are 20 payments, so N is 20. Okay, so let's first calculate the price. So you can see the payment is going to be 40. Future value is going to be 1,000. Rate, I can use 6%, but then I had to mention that this is compounding per year twice and payment per year twice. Okay. And the N is going to be 20. Then I'm calculating percent value. So let's use our calculator and see what do we get. Okay, so here payments are 40. 1,000 future value, 6% rate. Then payment per year 2, compounded per year 2, so second quit, 24N. Then I'm not sure the entire future value is enter again. Future value 1,000. Payment 40. Okay, I'm re-entering the same thing again. Okay. Anyway, now let's complete the percent value. So it's 1,148 and 77%. That's the percent. So now, if we look at the problem, now we know how much she really borrowed. She borrowed because this is the amount she borrowed to buy the bond. No, there's no leftover. So when you really borrowed this much to buy that bond. So borrowed what? 1,148.77 at rate of 5%. Okay. Yeah. So now let's go to the next part of the problem. all coupon payments are reinvested at a nominal rate of 4% convertible semi-annual. So let me draw the timeline. So here is 0, this is 0.5, and you are reinvesting that coupon amount, which is $40. And here is 40. And the last one is, like here you have 9, 9.5, 10. All of this you are depositing $40. Right away you get coupon amount, you deposit. Okay. So we need to know the future value here. So how do we do that? This is basically, if you look at this is annuity immediate, no? So annuity immediate, how many payments? 20. What's the rate? 4%, convertible semi-annual. Okay, so the rate would be 2%. Okay, you can see I2 is 4%. So the rate is 2% for the 6 months. Okay, so this is effective rate for 6 months. Okay. So I want to know the future value. So future value is basically 40 S. There are 20 payments under rate I. I is 2%. So let's calculate this one using our calculator. Set enter. This is annuity immediate, so no need to change anything. So 40 for payment, 20 for N. I can enter 4% or 2%, depending on what you like. If you enter 4%, then you have to say compounding per year twice, payment per year twice. Okay, so I'm going to enter 2%. So 2 for IOI, then second. This one. Then what else? Let me check again. 20 here. Future value is what we want. Present value is 0. 0 for present value. And I want to compute the future value. So it's 971. And it runs. So future value is. Okay. So now let's go back to the problem. So let's go back to the problem. So remember that at the end of the 10-year, we want to calculate the net gain. Okay. So let's calculate. So from coupons deposit, how much person is going to get? 971.89. And then you are also going to get that $1,000. Okay, remember the last at the bond maturity, you get the redemption amount. So redemption amount is $1,000. Okay. So the gain, I mean the how much you will get, 1,971.89. But you have to pay the loan. So how much you borrow? $1,148.77 at rate of 5%. Okay. And you have to pay at rate of 5% for years. So the borrowed 1,148.77 at 5% rate. So after 10 years, this is for 10 years. So it's going to be about 1,148.77 times 1.05 to the 10. Okay. So amount due. I mean the loan you have to pay that much. No? So this one gave us, let's see, 1,148.77 times 1.05 to the 10. And I would get 1,871.2252. So let's say 23. So that's 2 decimals. Okay. So now we can say the net gain is the difference. because you have to pay back this much, okay? Because you borrowed it. You are going to pay everything in one lump sum. So this will give you $100.66. Okay, so that's the net gain for that investment. Now think about that. If you did this for like large investment, instead of 1,000, you did the 1 million, and then you have nice profit from this investment. Okay? Instead of like just borrowing 1,148 to buy that bond, but what happen if you borrowed 1 million and then you borrow that much bonds and then realize that gain, then it will be a big net gain. Okay, so let's see this problem and see whether we can do it. And then this one says you have decided to invest in bond X, an N-year bond with semi-annual coupon and the following properties. Par value is 1,000, so face value is 1,000. The ratio of the semi-annual coupon rate to the desired semi-annual yield rate is 1.03125. The percent value redemption value is 3. Vn is plus the price of 1. So when I see this kind of like the present value redemption amount, right away my mind goes to the last formula we learned, McCam formula. So let's go to that formula. So here is the formula. It's G over J C minus K plus K. Okay, so let's write it down. What is K? K is the present value of redemption amount. So K is basically 381.50. And then the C redemption amount is a par value bond. So C is 1,000. Okay. Then the J, what is G? G is if you remember in here we define G as what? G as modified coupon rate, which is FR divided by C. Okay. So let me come back to the problem again. So G is FR divided by C, but face value and redemption amount are same because par value. Okay, so these two are same. G is basically R. So G divide, because of that, G divided by J is same as R divided by J, which is given in here. We use J, but they use I, so but it's same. Okay, so this quantity is same as R over I. So we have everything to calculate the price. So price become what? 1.03125. Okay. Okay, say the C is 1,000. K is 300. By the way, they given us Vn. So I'm thinking maybe base pair is not same. Let's try. Let's see. So K equals CVN. Okay, so K is given as 381 and 50. You have to be careful. They didn't mention its par value bond. It's just said the par value. So face value is 1,000. So maybe it's not par value bond. So maybe if is not same as C. So let's try it. So I know the C is here. Then the Vn is given. So it's 0.5889. From here I can get C. Okay. So what's C? And C is 381.50 divided by 0.5889. And let's see what do I get. It's going to be 647. and 8179657. Oh, so that means we cannot really use the so face value is not same as redemption amount. So this is redemption amount. So then let me correct this. It's not par value bond, it's just par value. Okay, so that's what, yeah, I made the mistake. So you have to be careful when you're reading the problem. So then the G, which is FR over C, F is 1000, C is 647.817965 time R. Okay. So let's cut, and then the G divided by J going to be 1. So then from here you can see G over J is basically 1000 divided by 647.817965 times R divided by J. This, let me use a different color. This entire thing is G. This part is G. Okay, from here you can see this is G. G equal this entire thing. Then when you're dividing by J, you are dividing this, you are including J there. Okay, so that's why you get J here. Okay. But then if I use a different color, then you know that R over J, or in here R over I is 0. So you can rewrite this one as 1000 times 647.8179 time R is R over J is 1.03125. So that should be what you get in here. Okay. So let this one. So let's calculate that quantity. G over J. So it's 1000 divided by 647.89, then time 1.03125. I would get 1.59. So this quantity equal 1.5918822272. Okay. So then the C, we just found C is this one, not 1000, because it's not par value bond, it's just par value is the given. So this is face value is the only one we know. And then K is 381.50 plus again K 381.50. So let's do that. Minus K is 381.50, then plus 381.50, and I would get 805. So the price would be $805.44. So 45 cents, 446875. So you can see that I was about to make a big mistake by assuming that face value is same as redemption amount. But then I started to think why they given us VN. Then I realized it's not actually a par value bond. It's just face value is 1000, not the redemption amount. But if I assume without looking at that face value and par value are same, I mean the face value and the redemption amount are same, then I would have gotten the incorrect answer, and then during the exam I would have chosen that incorrect answer. So you have to be very careful when you are reading the problems. Okay? Even your instructor can make mistakes. Okay, so so here is another question, and I'll do this one, and then the next one I will leave you to do. So let's read this problem. This is exam FA. So it says Bill buys a 10-year 1000 par value 6% bond with semi-annual coupon. So It's 10 year. Coupon amount is 1,000 times 6% with semi-annual coupon. Okay, so it's 30. And then it says par value bond. So the redemption amount is going to be 1,000. The price assume a nominal yield of 6% compounded semi-annual. Okay, so the J2 is 6%. So then the 6-month effective rate is actually 6% divided by 2, which is 3%. Okay, so for six months is 3% rate. As Bill receives each coupon payment, he immediately puts money into an account earning interest and annual effective rate of I. At the end of 10 years, immediately after Bill receive the final coupon payment and the redemption value of bond, Bill has earned an annual effective yield of 7% on the investment in this bond. Calculate. Okay, so let's just calculate the price of the bond. Okay, so what's the price of the bond? This would be FRANJ plus CVN. In this case, this would be 30. There are 20 payments. Rate J, which is 3% right here. C is 1,000. V to the 20. V is 101 plus J, which is 3%. And C is 1,000. Okay, so that's the formula. Let's use our calculator. So the calculator, if I use a calculator, payment would be 30. Future value is 1,000. N is 20. Rate would be 3%. But then make sure compounding per year and payment per year both are 1. If you set 6%, then you have to put compounding and payment per year as 2. So let's use our calculator and see what will be the answer. Okay, so 30 payment, 1,000 redemption amount, 20 number of payments, rate is 3, and then these are 1. You go next one also 1. So complete percent value, 1,000. So by the way, why it is 1,000? So if you need to observe that coupon rate is what? R is actually 3%. And in here, J is also 3%. If you have R and J both are same, then the price would be same as redemption amount. Remember, we had a formula earlier. Let me go back to that formula, which we calculate the amount of discount and amount of premium discount formula. So in here, if you have J and G both are same, then you would end up as price would be C, because then this would go to be 0. So if J equal G, in this case J equal G, because G is F bar over C, and F and C are, remember in the problem it's 1,000 because it's a power of 1. So G is R, which is basically I think 3%, and then J also 3%. So they are same. So this one going to be 0. Then you end up with discount is 0. So redemption amount equal price. Okay. So that's why there you get $1,000 exactly. Okay. So in this case, so you really don't need to do that calculation. Okay. So if you notice that G equal J, then you can just say the price would be 1,000. Anyway, so price is 1,000. Okay. So that's how much invested. Okay, so this is the amount invested. Times 0. Then when receive each coupon payment, he immediately puts the money into an account earning interest at an annual effective rate of I. At the end of 10 years, immediately will receive the coupon payment and the redemption value of the bond bill has an annual effective rate of 7%. Okay, so let's see what's happened with the account. So you're depositing the $30. Okay. So what would be the accumulated value of these $30? So you can see that the rate is account earning at annual effective rate of I at the end of 10 years. So the rate is not given, so it's I. So in here, future value would be what? So future value would be 30. This is annuity immediate, but we are calculating future value, so we use the S. How many payments? 20. I is actually effective rate, annual effective rate, but we need 6 months. So right now, let's use maybe I star. Okay, what is I star? Effective rate for 6 months. And we need I. So how I star and I going to connect it? 1 plus I star square equal 1 plus I. I is annual rate. Okay, so I is annual effective rate. They are connected, okay, using this formula. Okay, so this would be the future value. Okay, so now let's go to the problem again. It says Bill has earned an annual effective yield of 7% on this investment in the bond. So that means when you invest $1,000, at the end, how much you receive? Okay, rate is 7%, annual rate. Okay, so it says like this: at time 0, you invest $1,000. When everything after everything done, like you take the coupon amount, you deposit it back into the account, and after 10 years, you calculate what is the real yield rate. So here is 10. This is future value of your account. Okay, let me put future star because here I am also using future value. So let me put something like star. Then the rate would be it's this 1,000 grow under 7%. So basically, we are saying future value star equal 1,000 times 1.07 to the 10. Okay, because it's 10 year and this investment earns 7%. Okay, so what's the total accumulated value after the 10 year? Everything after everything done, how much really this person got? So 1.7 to 10 times 1,000. So this would be 1,967.151357. Okay, so this is future value. So now let's think about how this future value was gained. This is what? This is basically accumulated value of $30 coupon payments into account earning rate I. Okay, let me maybe write this. Coupon payment into an account earning rate I, which we don't know and which we need to find. Okay, plus what else? Plus 1,000 redemption amount at the end. So then really the accumulated value of $30 coupon payment is what? I can subtract the 1,000. And this is what? This accumulated value of $30 coupon payment. Okay, so that means 900. So let me subtract 1,000. 967.1513.573 equal to accumulated value of $30 payment. So which is basically this one. Okay. Let me use a different color. Which is basically this one. So I can write this is same as 30 times S20 rate I star. Okay. I star is 6 month rate. Okay, we need I actually, but we have plus 20 years. Okay, so now let's use our calculator to find the rate I. So I have future value is 967.1513573. I have payment as 30. Okay. So since we are depositing what we receive, like coupon amount into a gain, so it should be negative. Okay, this one is positive, but this one is negative since we are depositing again. It's going out of our account, our pocket. Okay. Then N is 20, present value 0. And then rate, that's what I want to find. Since this is 6 month effective rate and actually payments and compounding done only once. Okay, so let's enter this into calculator and find rate. So second, reset enter. One, 513.573 as future value. And 30, but you have a negative sign in front of that as payment. 20 as N. 0 as present value. And then second here it should be 1 and 1. So then compute rate 4.75. So this should be 4.76, which is basically 0.0476. Okay. Remember, calculator give us percentage. So now this is 6 month effective rate. So for 1 year annual rate, it's going to be what? 1 plus 0.0476 square equal 1 plus I, and then from there we can get I. And I is going to be 9.7465. So I will leave the last question for you to try, but this give you some idea like how to do SOA exam problems and what kind of problems you are going to see in there. Let's meet again with the required yield.